Hi folks, so today what we're going to be doing is learning how to inscribe a parabola in a given rectangle, as you can see here. And before we just get started, I'll just do a quick introduction on what a parabola is and where it actually comes from. So if we revert over here to the orthographic little sketch that I've done here, we can see we have the elevation of a cone, okay, which will be represented by a triangle in the elevation view, and we have the plan view down here, which will be represented by a circle when we look down the top of the cone. Now a parabola is generated when you have a cutting plane that is parallel to the extreme generator of a cone. So we can see our cutting plane here in red, okay, that is cutting our cone, okay, but it is parallel to the extreme generator of that cone. And when you have a cutting plane that is parallel to the extreme generator of a cone, what the curve that it actually generates is what's known as a parabola, okay, and you can actually see it in the name parabola, parallel parabola. Okay, and the cutting plane will be seen as an edge view in our elevation, and down in our plan we can actually see the parabolic curve down here. Now that's not the true shape, but that is what you would see when you look down the plan view. Okay, just some terminology along there. The line that's running through the middle of the parabola, okay, that would be our axis, so that line going up there. At the top of the parabola we have the vertex, which is indicated by the V, and bottom points down here A and B, which I'm going to relate to over here when we do our parabolic curve. Okay, so when doing a parabola, inscribing a parabola in a given rectangle, there's a couple of steps that we have to follow. First of all, we have to locate our vertex, okay, which is the top point of our parabola. Because as you can see in the sketch down here, we have a point A and a point B, which are at the bottom of the curve, and we've already got those. So them two there are points straight away, starting off, A and B. And now what we need is our top point, which is going to be somewhere up here. And we'd have to imagine the vertex is going to be right in the middle of the line DC or CD. So straight away there, starting off, what I will do is I would bisect that line C to D. Okay, so just bisect that line, do it up here. Okay, I've bisected that line, and now I've indicated the point V, which is my vertex of the parabola. Okay, that is an axis line, so what I'm going to do is I'm going to draw on my axis line. So an axis line is long dash, short dash, long dash. Okay, there's my axis going right up the middle. Now, the steps to drawing a parabola, what we're actually going to do is we're going to use division of lines, and we're going to use a little bit of axial symmetry, because once we have the parabola drawn one half of the parabola, we can use axial symmetry from transformation geometry to complete the other half. So what I'm actually going to do is I'm going to complete it on this half of the page here. Okay, so the parabola is going to have a curve that looks something like this. Okay, if you follow the trace of the pen there. Okay, and what we're going to do is we're going to get the first half of it up to V, from A up to V there, and then we'll complete the second half. So what I'm actually going to do is, first of all, I want to divide these two lines from D to V and A to D or D to A into equal number of portions each. So if I was to divide D to V into 4 portions here by doing division of lines, well then I would also have to divide A to D into 4 portions here as well, doing division of lines. Equally, if I did 5 portions, then down here I would also do 5, 6, 6, down lower 3, 3, and so on. Okay, so I'm going to pick a nice easy number there, and I'm going to do 4 portions. Okay, so what I'll do is division of lines. So from A, I'm going to step off a random distance at any angle, and I'm going to do 4 tens, step out 4 tens, so 10, 20, 30, and 40. At the last point there, connect it up to D, and from that point then, I'm going to just do a little bit of sliding set squares. And at those points there, I have now divided the line AD up into 4 equal parts. Now, because this is my axis line here, I'll actually just write that in. The points that are running along the side, what we're going to do is we are going to connect all of them up to V. They will all connect to the vertex. There we go. Okay, every one of these points that we divided up into 4 equal parts, this point, this point, and this point, all connected up to the vertex. Now what I'm going to do is I have to divide the line DV up here into 4 equal parts as well. Also equally I could do it down here at the bottom, and just because I have a little bit of space down here, I'll do it down here now instead, just to keep it neat and tidy from up there. So exact same method, 4 equal parts. I do not know the measurement of the line. If you did know the measurement, you could use simple maths, but because I don't know the measurement of the line, I'm going to use division of lines. At the last point there, I'm going to connect it up to here. And then once again, divide my line up into 4 sections. So sliding set squares. Okay, now to locate points on my parabolic curve, I'm going to have a point somewhere along this line, somewhere along this line, and somewhere along this line. And what I'm going to use is I'm going to use these points that I've gained down here to locate them. So at these points down here, what I actually do is I go upwards parallel to the axis and to the vertex. Okay, so what I have to do is literally go straight up. Okay, but it's always going to be parallel to the axis. So in that case, obviously this parabola is in line with my t-square. The base of the parabola is in line with my t-square. So obviously if your parabola was maybe twisted, then you always just have to remember you go parallel to the axis. Okay, so at this one here, I'm going to connect it up, and this one is going to match up with the top one up here. Okay, so there's a point on my parabolic curve. The next one is going to match with the next one down. So the further I'm kind of going away from the axis, the further I'm going away from the top of it here. And then the exact same down here, the last one will be a point right there. Okay, so once again, further I'm moving away from the axis, further I'm moving away from the vertex. And what we can actually see is we've got a point here, 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 and here, all on my parabolic curve. So I'm just going to sketch that in there quickly, so I'll speed up the video. Okay, as you can see, we have now completed the first portion of our parabolic curve, and we are going to have essentially an identical portion of the curve over here. Now, we could follow the exact same method by dividing this up into 4 equal parts, dividing this line up into 4 equal parts, and it would be very simple because I have my measurements done here. On this side, obviously, I could just take this measurement and step it out 4 times as well. But another way we could do it, and just by completing it, is I've also located this point, and this point in here originally. So what I could use is just a simple bit of axial symmetry to complete it. So from there, I'm going to step over a couple of lines, and now using my compass, I'm going to place my compass on the axis line and take the copy of this point here and project it over to the opposite side by swinging an arc. So right in the axis line, this distance here will be the same as this distance here, and the last one up here gives me that point there. So once again, just going to quickly speed up the video there now while I sketch in the curve. Okay, there you go. That is a video there on how to inscribe a parabola in a given rectangle. And as you can see, the rectangle at the very start was A to B to C to D. You'll also notice at the very bottom I have it in my line A to B, because if we revert back over here to the little sketch that I had done previously, A to B is the cut surface at the bottom of our cone, so that is actually a heavy line. Okay, so that there is literally how to inscribe a parabola in a given rectangle. Dividing up the sides here on one side, dividing up half of the sides into equal number of portions, connecting the points along here to the vertex and down along here, connected up vertically until they cut those lines, and then a bit of axial symmetry on the opposite side. Once again, hope you found that video helpful. That's the video completed there.